So hopefully we get the slides.
So there's no way to set a deferred execution or a delayed execution on a protocol level. But there's a ton of use cases for scheduling. Scheduling is something that people are used to. It's something that, at least when I first started developing with Ethereum, I ran into wanting to do it a lot. And a lot of people I've talked to have asked me about it. And almost everybody has, at one point or another, needed a way to schedule a transaction. So some of the use cases of this are like true smart contract automation. So being able to have contracts that can schedule other contract calls.
So my name is Logan Saether. I'm from Chronologic. I'm a smart contract engineer.
Indefinitely.
I'll be giving a talk
contracts
about
are funded.
scheduling on Ethereum.
Why that's a problem,
of course,
and how we're
things
going
like
about
ICOs,
solving it.
depending on time zones, people have to stay up really late at night or early in the morning. It would be a lot easier if we could just schedule those transactions to go through when the ICO opens.
So
we have things like the ENS, which has a two-phase kind of system where you first commit and then you reveal that commit. So using a scheduler, you could have both those transactions set at the same time, so you don't have to remember to come back 2 days later. And then there's things like recurring payments. So it's actually a ERC right now, ERC 948, about reoccurring payment standard. For that, a scheduler could be really useful. And so the way that scheduling has been solved up until now has been server side. So a lot of people have set up client side, like cron jobs, that will send these transactions out at a specific time. The problem with that is that these client side scripts, if they fail, then your transaction doesn't go through. But then, so like what if you have more than one server set up? You have two servers, the chances of two going down is less likely, but it's possible. So the optimal solution for this would to have a lot of servers that would be watching for an execution. And this is kind of the idea behind what we've been working on, which is the Ethereum alarm clock. So it's a decentralized
and then that time node will get the bounty
execution server, basically. And I'll go into a little bit more about what that means. So the Ethereum alarm clock project is an open source project started by Piper Miriam. It was started in 2015, so it was one of the first large-scale dApps built on Ethereum.
And it's
but it's ever since the 2016 DOS attacks, it's been non-functional. Piper has been getting involved in other projects, and his bandwidth isn't enough to continue the alarm clock project, so it's sat non-functional for a while.
So one of these problems,
until Chronologic came around in late 2017,
transaction collisions,
and seeing all the seeing the gaps in this functionality, decided to pick it up and to start it up again
at the same time, and one of those transactions will
fail
and get reverted.
So here's here's kind of a diagram of the alarm clock internals. This isn't the most up to date. We kind of pruned this down a little bit.
So it's kind of the same.
Working on getting the latest version.
A miner can also be running a
but
time node,
in a nutshell, the way it works is it's a smart contract protocol. So when a user wants to schedule transactions, they send
and then we have the problem that
the parameters
when a user
to a smart contract,
they set the gas
which
price
will
that they
deploy
want
a new smart contract with these parameters.
There's no
in
way
storage.
to tell what the state of the network might be
And
when
then
that
we have
is executed. So the gas price
a lot
might be something
of servers, basically, which we're calling
so
time nodes. And to
these
kind
are,
of tackle some of these problems that we have, we've been working on what we're calling the Chronos Protocol,
the free
which is kind of the
anyone
alarm
to
clock
run
one of these time nodes.
on
So
steroids.
the idea is that instead of running
test
your
bed
own
for a lot of
personal
experimentation.
execution script on your
So
server. If
what
you
we're
run one of these, you
experimenting in the
contribute
Chronos
to the
Protocol
community
is
of
conditional
executions,
scheduling as well as temporal scheduling.
and
scheduling.
also these
so this would
time
be
nodes
something
are
that would
incentivized
watch the state of
because
contracts.
when a transaction is
And if
scheduled,
the state of a contract
the
changes,
scheduler
or if the state of a
will
contract
put a little
fulfills,
bit of Etherium as
these
a bounty,
conditions, it'll send out an execution.
so they can get a guarantee that
So to solve
a time
the
node will
transaction
indeed
collision
execute the
problem,
transaction.
we're revamping the
so
claiming mechanism, which is the way that
the-
time nodes are able
The
to
benefits of this is everything is verified on
just
chain.
claim that they're
So
going to execute a
if
transaction when
you
that
set the
transaction
parameters,
is supposed
you
to be
know that
executed. We're
there's
experimenting with
no
using
other
tokens for this as
transaction
a
that
kind
will
of
be executed instead.
staking or bonding
If the
mechanism.
transaction
So
is
a time
executed,
node
it'll
will
be
put
executed
a
exactly
bond
how
that they're
it
going
was
to execute this
set to be
transaction, and
executed.
if they don't, they will lose that
Um,
bond. And then we're
so
experimenting
we've
with
been
ways that
Developing
we
this
can-
ecosystem around
this
the
would be
alarm
able
clock.
to solve that transaction
right now
collision
on
problem.
the Coven testnet.
We're
we've
also
built
trying to
JavaScript
optimize
libraries
the gas
to
cost
interact with them.
as much as possible.
So
So
we've been working on the smart contracts.
the current Ethereum alarm clock can
toward
be
a
expensive
1.0
because it does a
release.
lot of storage calls.
And we have the
because it
contracts
keeps
in
all
a-
of the parameters in
middle of a
storage.
security audit at the moment.
Basically, the
we've
solution
also,
for that is
integrated
just
this
to
into the
hash all of
MyCrypto
those
beta.
parameters
So,
and
what it
check
is
the
is
hash when
on
the execution is sent.
MyCrypto, send transaction
And then we're,
there's a switch that you
since
can
we're
hit
just storing the
says,
hash, we're
send
basically
later,
sending all of the data
and it uses
as
the
event
alarm clock
logs.
on the back end.
So
And you
we
can just
we
send,
might
set the time
use
that you want that
IPFS as
transaction
like a
sent
storage
instead of
backend,
sending it
but we
right
might
away.
not even need to use IPFS
And then-
as long
and then
as
we
the
also
time
have
nodes
a
are all
full DApp that we
watching
built
the
out
event logs.
for both scheduling a transaction and running a time
And then
node.
we're
That's available at
really
app.chronological
paying attention to
network. Everything
plasma
is
and
live
state
on
channel
Logan
uses
currently.
because
Until we
both
get
of
the security
those
audit back, then the plan is to put it on the main
both of
net
those projects
as soon as
need
we're,
time-based
confident that
executions
the contracts are set.
for the exit mechanisms. And so
So
we're
a little bit more about
one of the
what
goals
the
with
time node
Chronos is to make sure that
It's basically just a
it would be interoperable with second layer scaling solutions like Plasma or state channels. So all the code is open source. You can find it on our GitHub. There's a link down here. If you have any questions, feel free to talk to me or a member of our team outside. And also we have an active Gitter. So we have the Chronologic Gitter, and we also are active on the Ethereum alarm clock Gitter. So if you want to use the alarm clock to build on, we have tools at every layer of the stack, JavaScript, Solidity, and we have a DApp. So come talk to us there. Come check out our GitHub. Thank you very much.
That's awesome. Thank you.
Great GIF game, Logan. Great GIF game. Awesome. Yeah, great talk. We're really